Hi, everyone, and welcome to the MLOps Live webinar series, where we discuss how to bring data science into real business applications. My name is Edie, and I'm the head of demand generation at Iguazio. It's great to see so many of you here with us today. We're really excited to be hosting Noah Gift, author of the book Practical MLOps, published by O'Reilly, on this session. For those of you who are not familiar with Noah Gift, he has written over 9 books, including 4 for O'Reilly. So with us today is Yaron Haviv, co-founder and CTO at Iguazio, MLOps visionary, creator of Nucleo and MLRun. Together, Noah and Yaron will be discussing best practices for succeeding with MLOps. We'll be getting started in just one moment. Noah will start us off by discussing MLOps trends and techniques, MLOps strategy, and best practices. Afterwards, Yaron Haviv will discuss the importance of adopting a production-first approach to see real business value with AI. He will share the 4 pillars of MLOps acceleration and will finish off with a live demo. Before we get started, I'd like to invite you to join over 500 data scientists and practitioners on our MLOps community. This way, you can ask us questions and continue the conversation even after the webinar ends. We'll drop the link in the chat now. These polls help us make the session as valuable as possible for you. And as always, we'll make sure to share the results.
Hi, happy to be here today. I started my career off in my early 20s working on 3D animation pipelines. And what was interesting about those kinds of pipelines is that they're actually the origins of modern data engineering. All of the same components that we're seeing today with distributed systems, network file systems, high performance compute, all was available. And Disney feature animation, Sony ImageWorks, a lot of the stuff I did was automate tasks, make things so that there was images that deployed, scripts that would move things through a pipeline. And so I think many people don't know this, but animation has really been probably the closest thing that we have today to what's happening with MLOps. So it really gave me some good perspective about what's happening currently. Recently, I've written quite a few books, including over 9 with 4 for O'Reilly, and there's more on the way. And in about 2013, I built a sports social media company. And a few things that were interesting about this was, one, at the time, I think social media wasn't as big of a deal as it is today. There's lots of discussions about it, but we were focused on sports, which is pretty non-controversial. And it was kind of fun because we were able to get to millions of users, millions in revenue from zero. And we did it with MLOps. And so that gave me some good perspective about how you can actually create revenue from machine learning. And that's really a focus of mine today. And what I do currently is I consult with MLOps for Fortune 100 companies, startups. I also recently wrote the book Practical MLOps, and I've also am starting on a book with Yaron actually for O'Reilly called Implementing MLOps in the Enterprise. So let's get into why MLOps. I think one way to think about this is that life is precious and you need to get to work on stuff that matters. And what we're currently seeing is that the ROI is not there for data science. Data science is, I think, a very useful skill, just like reading comprehension is a very useful skill. Periods of my life, I've read a book every single day. It's a very important skill to be a reader, but it's not necessarily a job. And I think we're seeing some of this with data science, where it's an important skill to have data science, but that by itself isn't enough. We need more. And as I mentioned, life's short. We need to get results. Who knows what the future will bring. Let's get results today. And also, I think we need to use high-level tools, not just low-level things that maybe get us caught in the weeds. And that's why I'm a huge fan of platforms. One of the things I'm seeing, and I think many people are seeing this as well, and in fact, now with a potential recession coming, I think what we're going to see is more consolidation around engineering-focused jobs, data engineer, machine learning engineer, MLOps, and less of a focus on more theoretical type work. And this is from Wall Street Journal in 2020. where there was close to 1 million jobs, doubled. I think this is really an area of growth, and we're seeing a lot of engineering focused jobs emerging. One of the things that I have really been focused on for the last several years is this concept that there isn't a silver bullet. And again, this is my opinion, is that when you talk about data centric or model centric, I think you're missing the point. I think the point is that it's a holistic issue when you're talking about MLOps. DevOps is a huge part of MLOps. It's the automation of your software system, infrastructure as code, deploying software automatically, data ops, being able to automatically get clean data into your system. Also with modeling, automating as many things as possible, using hyperparameter tuning, maybe even using pre-trained models. But even if you do all of those things correctly, the technical sides, there is the business component, which if you're spending all your time on just the technical, you won't have enough time to reflect on the business side of the problem. And so this is, I think, really an issue for many organizations, is they're not focused enough on thinking about framing the problem correctly because they're spending so much time in the weeds. And so this is why I would say there's no silver bullet, that there needs to be a holistic approach when you're dealing with MLOps. So let's talk about some of the strategies for MLOps that I found could be helpful. And this is even helpful beyond just MLOps, just in my career, is that also there's no silver bullet for platforms and technology providers. I would actually be very concerned if you ever hear somebody talking about the one true way to do anything, or the only way that's successful is this, or we see these kind of hype in technology all the time that really isn't a solution, the one true way. It's better to be thoughtful about being able to adapt to the future, maybe having 2-3 different solutions, and picking things based on data, not just on an opinion about some technology. So what are some of the criteria that you could use? One of the criteria that I use for a primary investment in technology is that there's a low cost associated with the technology. And I think this is critical. Like, are you picking things that are efficient? Also, popular. This is important as well. Are you making sure that you're picking technology that has a future? Is it going to be easy to hire with that technology? Is there breadth to it? Like, does it have an array of features? And also, can you build on top of that technology solution? So I think this is an important consideration for primary. A secondary investment, so let's say another kind of technology for your organization. Do you solve one problem extremely well? So good examples: Iguazio, Databricks, Splunk, Snowflake. Depending on what kind of situation you're focused on, it's important to have a vendor that can be very specific with solving a problem. Not they solve all the world's problems, they solve a problem and they do it well. And then another thing to consider is just maybe conceptually this concept of investments. So what are you focused on in terms of R&D? Do you need to have some deep learning technology? Do you need to have some Kubernetes technology? Do you need to do something with edge computing? Should you be looking into pre-trained models? I think this is a framework that is reasonable, that is scalable, even again beyond MLOps. And I've used similar approaches when I've worked in industry. So here's a little bit of consideration for primary. Again, I look at data to make decisions. The data is pretty clear. Amazon is probably one of the vendors you should consider if you're in the cloud market for primary. Azure is also a pretty compelling vendor. Google Cloud maybe a little less compelling, but in terms of the data here, AWS and Azure are very strong. Now there could be regional considerations as well, and in particular, if you're in Asia, maybe Ali Cloud could be the stronger choice, or Tencent Cloud. But it is interesting to look at a data-driven approach to what technology, and also, are you going to get support? I'm a huge fan of actually being able to get support. Are there standard certifications? Is it easy to hire people, easy to train people? Is there a lot of documentation about the technology? Now, in terms of secondary, this is, again, as I mentioned before, is there something that specifically solves a problem? Well, ETL, log search, monitoring, model serving, right? And so in this particular diagram here, we can see that, in fact, there are vendors that are better at platform plays, feature play, innovation, maturity. And so it's important to consider very deeply, is the solution that you're picking? You see here, Iguazio is on this list. Is it able to actually solve a problem that you need? In fact, we can see as well it's fast mover, so they're able to kind of go to where the action is, right, in terms of the industry. And also, a thing to consider is, do you synthesize well with the primary platform, right? For example, does the secondary platform have good integration with the cloud vendor? And then I think another one to consider is, are you building on top of, is this technology solution building on top of other robust technology, like in the case of Iguazio, Kubernetes, where you know that there's a significant kind of wind at the sails effect. Okay, let's talk a little bit about hiring and upskill strategy. One of the things that I would recommend for organizations wanting to get better at MLOps is to get a subscription to a learning platform. I'm a huge fan of O'Reilly because I work with them quite a bit, and I've written a lot of books for them, and I'm writing another book. I think that's a great one. Coursera is another great platform, but in general, this is a great way to encourage growth in your organization, is to pay for technology learning platforms. I would say maybe a couple at least. I would also encourage people in your organization to get certifications, so the management, I think it's well worth the cost to help your staff and organization, especially if you're picking a new technology. You need to have evangelists internally into the company that can help with the technology and do monthly tech talks. I've actually spent a lot of my career doing this in companies, and also doing demos as well. So are you able to demo things to your organization? Have yearly and quarterly learning goals. These are really critical too. If you don't set a goal, then it's really impossible to know, are you achieving anything, right? If you don't have goals, really life is almost meaningless, especially in a technology company. And as I mentioned, pay people to learn, I think, is good. The other thing I'll say about the encouraging the demos is that there is a lot of research around this. It's called metacognition. And there's a great book that talks about it, Know Thyself, the Science of Self-Awareness. But basically, the more you teach something, actually, the deeper you get at acquiring that skill. And so that's why I think this is one of the best techniques you could possibly do when you're adopting a new technology in an organization. So let's talk about a few of the key MLOps certifications here. So I think AWS, as I mentioned, is definitely one of the main players here for certifications. The AWS machine learning specialty is pretty good. I was involved in that, the creation of that actually. Data analytics is a very good one as well. Solutions architect. I think these, even if you're using other cloud vendors, I think these can be really useful as like a level set, because in particular, like solutions architect can help you understand the concepts of cloud computing. Now, if we get into other kinds of certifications, we have, Snowflake is an emerging platform. There's a lot of action around it. Databricks, maybe Spark section in particular could be very interesting. Kubernetes application developer could be really helpful. The machine learning engineer certification for Google Cloud, even if you're not using Google Cloud, just the concepts. And then also MLRun. There's a lot of documentation and open source solutions, especially with their marketplace. All of these kinds of technologies, I think, are helpful to just set a level set so that you understand the terminology. Okay, let's talk about some future trends in MLOps. These are some of the things I think will happen. I would say I'm reasonably confident in making like a 1 to 2 year prediction. I feel like I've made some of these and they worked out. So one of them that I see happening, and again, this is because for decades I've worked with centralized file systems that were shared over the network, is I think NFS and also Windows storage systems like NetApp, Those kinds of systems are definitely going to, or FSX on AWS Cloud are doing a comeback. In particular, here's a good example here where you would have EFS, which is the source of truth, and EFS is basically a managed NFS file server. You could have a cloud-based development environment, let's say Cloud9, and because it mounts the EFS system, you have this great feedback loop where as soon as you push code into, let's say, GitHub or maybe a cloud-based, Git repository like GitLab or even a cloud vendor, that you can actually trigger a build, and the build would be the build server would essentially rsync the code over to the file server. So this could be a 200 millisecond deploy, and the scripts, maybe the container, whatever, gets synced inside of this network file system. And then you actually have access to this EFS volume with thousands of deep learning nodes or thousands of containers. And there's a lot of workflows that this enables, that it simplifies things. Instead of going through like a Hadoop file system, which you have to have a cluster you manage, it actually gives everybody access to everything. So I think this is a very interesting area to look at. Another one is Kubernetes, Kubeflow, this whole ecosystem, again, similar to some of the technology that is underneath the hood of Iguazio, that, there are some really good developers working on Kubernetes. And you can think of Kubernetes as like a cloud in a box. And so you can see there's a ton of different resources that are being integrated into Kubernetes. And even if you don't use all of the deep low-level things with Kubernetes, it's likely that either you're going to use a technology that's influenced by Kubernetes, like in the case of Amazon ECS, or you're going to use an abstraction like EKS that helps manage it. But it's something to definitely pay attention to. It's not going to go away. The other one that I see coming up quite a bit is edge-based machine learning, where you would use a framework like TensorFlow, you do some transformations, and then you would deploy to many different endpoints. So not just deploying to, an API or to some, maybe batch-based job, but you would deploy to an edge-based device, because there are many edge devices that people are using to solve problems. I was involved in a project at Duke, actually, where edge-based software was used to detect rare animals and, to let conservationists do things with them. Also mobile phones as well. Pretty much every mobile phone now has specialized chips that allow you to do inference. So I think this is not going anywhere as well. Edge-based machine learning is going to be on the rise. And I think also this is where pre-trained models could really play a role, is we'll see more of these. And also tools like Apple's Create ML, which is pretty interesting actually, in that you can train models using their specialized hardware. And I'm actually a pretty big fan of that technology. The other thing I think that is not talked about enough, that is a big deal, is this concept of ESG. And we see there's a lot of things in the news about ESG, and people are upset or they're happy, or, there's all kinds of controversy about it, but it's not going away. It's probably going to change and morph into other things, but in particular, being conscious about the environment. For example, are you training models that you don't need to train? You're just basically doing Bitcoin mining at that point, right? Like, you're not necessarily solving problems. There may be more of a push to use pre-trained models, and also for security, social responsibility as well. I think we're seeing more of this, that the ethics of AI and what the impact is definitely going to play a role. I don't see this diminishing. And then governance, what's happening in terms of your governance. Are you doing things that are ethical? And so I think we'll potentially see big opportunities here, where there may be companies that are not embracing ESG, and I think they will actually be avoided. I think most of the new generation wants these kinds of approaches. The other thing is pre-trained models and AutoML. As I mentioned before, just because you didn't train it doesn't mean you don't use it. Like, we see this all the time with food. If you go to Costco, it would be like saying, hey, I didn't make this pizza, I'm not going to buy a Costco pizza. Well, Of course, people don't say that. I mean, maybe a few people say that, but in general, there are different levels of abstraction, right? You could say food could be machine learning, flour, train a model, frozen pizza, AutoML, pizza delivery, sentiment analysis, right? There's lots of different abstractions when you're actually picking food to eat, and you choose which level to eat the food at, right? Or to build the food at. Same with machine learning. They're all valid solutions depending on the problem that you're solving. And this is not going away. It's only gonna get bigger. The other one is model portability. And I think this is yet another issue where, there could be many different people working on models across different organizations, different companies. And I think we're going to see more and more traction around this concept of model portability, like Onyx. Basically you build it in one language and you port it to another. Apple, again, CreateML has the CoreML framework or CoreML model type, and you can convert that to, say, TensorFlow. There's I think a lot of really fun stuff happening here that we're going to see. And then one other thing I'll mention that I think is, to me, is a little bit amusing because I teach data science, is that many people get very upset when you bring up the concept of AutoML. But the reality is that everything has to be automated. That's what Kaizen ML is in my mind. So when you're talking about AutoML, you're missing the point to some degree about what's really happening. This is an industrial revolution, just like there was industrial revolution with steam, industrial revolution with electricity. We're in a new industrial revolution, and it means that everything's going to get automated. And so data is going to be, basically a competitive advantage. I think AutoML is only going to get better. It's probably going to be a commodity at some point very soon. And I think you were also seeing that ML engineer and data engineers are definitely in demand. And so when someone says AutoML, I think probably many times what they really should be saying is more talking about the automated process improvement versus just getting caught up in AutoML. And so this is where we get into the production first mindset. And in my mind, this is really the way to think about the problem is, instead of getting hung up on 5% of the problem, which is AutoML, why don't we think about the entire thing and automate the entire thing? And so auto data engineering, auto feature engineering, automatic testing, building from the very beginning with source control, doing business intelligence, automated data drift, elasticity, all of this. Ultimately, the point is to get the system into production. So here, I think I can turn this over.
And thank you, Noah, so much for all of those slides and for diving into that. It was really interesting. We're going to go ahead and take a quick break, and I am going to show the first poll question for participating. I'm going to pass the mic over now to Yaron.
Okay, do you see my slides?
Yes.
Great. So last thing that Noah was talking about, and really thank you, Noah, for this enlightening talk, is the production first mindset. And this is something we've invested a lot of energy, and we're developing MLRun as an open source project, which essentially tries to follow this approach. And when we talk about, and what I'm going to speak about in a couple of minutes, and then I'll show a demo that implements that approach. So when we think about production first mindset, we don't only want to think about training a model or even serving a model. We need a more holistic view of the application. We need to think about the data generation, and not just grabbing a CSV file, but how do we really generate data from live data sources, whether it's Kafka or Snowflakes or a file that just landed on an object store. And then when we're doing training, we also need to think about continuous training, retraining, and so on. And when you retrain, you have to refresh the data, snapshot it. You need to track all the results. You need to test your model. You need to generate deployments. And as Noah mentioned around serving, you don't just serve a model. You have to do some data engineering to join different data sets for the scoring event. You have to do scoring, sometimes data validation, sometimes interact with different APIs. Take the results, store it, monitor potentially some business metrics or model accuracy, and so on. And the last thing is to essentially collect the feedback loop, is monitor the model, monitor the data, monitor the business matrices, and take those and write them back into the feature store so you can use them for further training, explainability, and other application. And all of that needs to be automated. You need to be able to do rolling upgrades. You need to build things that work at scale, highly available, secure, and so on. And this is a huge engineering effort. So what I'm going to show is how we're trying to tackle that with MLRun by essentially implementing 4 key components in MLRun that are all open source. The first is a feature store that deals with grabbing data from a variety of online, real-time or offline sources, building the features in an automated fashion, fully automated using serverless engines that sit underneath, then bringing that those features, snapshotting them, and creating a training pipeline, fully automated training pipeline. It could even be integrated into your CI systems or Git, which builds, tests, and builds the models. Finally, you build the serving pipeline, which can again comprise of multiple steps, enriching real-time features, scoring, data validation, actions, and so on. And finally, building a real-time monitoring for the entire solution. So with that, skip that. So just to understand how MLRun works, in order to build, MLRun has several components. We talked about feature store and real-time pipelines and monitoring and so on, but the focus here will be more on the automation, on building sort of continuous applications. So the general idea, you can compose pipelines. The pipelines are not just machine learning. They could include the feature engineering portions, the code integration portions, training, test, and validation, and even the deployment of those models into a test cluster, or later on deploying those models in full applications into production clusters. And they're essentially this mechanism essentially plug into whatever pipeline engines you have, whether it's using Kubeflow pipelines or GitHub Actions or GitLab CI or Jenkins, etc. And it also tracks the entire versioning of all the different artifacts that are generated, data sets, models, experiments, and so on. And everything is auto-scaling and elastic because the underlying implementation of each of those elements is a serverless function that sits behind and can auto-scale and can scale horizontally to huge scale. And there's also a function marketplace that allow you to reuse code. So if, for example, you want to do training, you don't have to implement the training function again and again. You could just grab a training function from the marketplace and use it with your code, or grab a serving function, or grab a data engineering function, and so on. What I'm going to show you is an example of a predictive maintenance demo that uses real-time telemetry data. So think about the data. I have 3 different data sets. One is static device table. I have devices. So let's assume some network device that emits, different attributes, maybe a device in manufacturing. And it has things like model and country and version, and maybe last time it was handled, and so on. This is sort of a static table. A second thing that we have is real-time telemetry, whether it's temperature or vibration or CPU and memory and or temp and so on. And we can take all those and they feed in real time. Think of real-time time series matrix that feed into the system. We're feeding those using the real-time Nucleo engine, but you don't even need to develop those. The feature store essentially builds those functions automatically for you. And the last data element that I have is a real-time device label. So every time I have a failure on a device, it essentially generates a notification, which is getting registered as a label. So later on, I want to predict the failure based on the other metrics. All of that data is ingested into the feature store, where I could do interactive exploration. And then every once in a while, I can just create a fully automated pipeline that snapshots the data set, runs training, testing, deploys the serving pipeline. And then we have the serving pipeline, which interacts directly with the real-time feature store. And finally, we have the model monitoring that monitors everything. So I'll try and do all that stuff using two notebooks. Let me swap my screens. Everything I'm showing you is part of the MLRun demos. There is a demo called Network Operation for Predictive Network Operation. It's a Git repo. You can clone it and see the same things that I'm demonstrating. It essentially has two notebooks. The first notebook is about the feature engineering, creating features that will be used in production. And remember, I mentioned three different data sets, the device data sets, the time series matrix data set, and the labels. In order to build a set of features, I'm just creating a feature set object, and I define my transformation. This one is a very simple transformation, one-hot encoding of my features. And then essentially, I can see that I can build this analytical pipeline. I can simulate that in a notebook, and I can save that, and later on that thing will go into production, and I could define periodic ingestion that it will do it, every hour. I can, attach it to a stream like Kafka stream, so it will be running updates in real time and so on. But developing those features is essentially extremely simple. You see all those one-hot encodings on my data set. You can also build much more sophisticated pipelines, like this is building time series aggregations and other things on the data set. This is sliding windows and all this complexity that you want to build. Again, single line or a few lines of building analytical pipeline, and then I could simulate the results. I can see that it generated time series aggregations across my data set. When I'm ready, I'm just going to save this feature set. Same for other feature sets. Again, I can just build pipelines. This is a simple example. There are, like, the fraud detection demo that's much more advanced. There are about 14 different transformations happening on the data set. And you can see this is also doing some encodings, etc., on the data set. In order to launch this to production, it just, we could just use the ingest method, or we can just launch a real-time serving pipeline, or sorry, a real-time data engineering pipeline by calling one command saying deploy ingestion service using our feature set, the definitions of our feature pipeline, the source. In this case, this is a real-time stream. And this will essentially automatically build serverless functions that listen on Kafka and process the data. So this is what I needed to do to build all these feature engineering pipelines for three different data sets. That's probably, if you do it manually, it's probably a few months work just building all those pipelines for production with scaling and all of those things. The next thing I did, once I built the features, I want to train models or build the training pipeline for that. And I don't want to do it with too much engineering. So I create a project, and then I build a feature vector. My feature vector defines how all those different data sets combine. So the features is essentially taking the device matrix and joining them with the device static data. The label is a device label data set and some field called isError on that data set. This is my definition of the feature vector for training. I can just go in and create that feature vector for building something interactive. So I can just say get offline features. Here's my feature vector, and just visualize it. So you see, it's essentially all those different features that I built before. They're joined together. The static data with the time series data, and even the labels. They're all automatically joined. No need for a huge amount of energy on data engineering. And that's it. Now I want to create all of that pipeline of essentially creating the feature vector. Remember that we're building a feature vector that if we're retraining, we have to build a feature vector every time again and again. Maybe if we're training every week, we have to create a snapshot of the data for the week prior to our training. So we need to move the window around for our training, and we want to do it automatically by schedule or event-driven. So what we want to build is a workflow. This workflow consists of creating a snapshot from the feature vector, training a model, testing the model that we generated, and deploy the serving pipeline after that. The workflow is really simple. It's essentially running a few functions in a pipeline. It's using the Kubeflow language, but can also be running without Kubeflow locally. So the first step that I have is is essentially getting the offline feature. If I have this prefix hub, it's essentially going to the marketplace. This is a function that I don't have to implement. So I can even pass like the time, start time, end time for that snapshot. I can do the training, do the testing, and finally doing the deployment of my pipeline. So the minute that I'm going to run this symbol command, I can give it like start time now -7 days or some other variable. And this will essentially automatically build the pipeline that will go and automatically generate all those things that we talked about. It also integrates with Git and CI/CD. So once I've built the pipeline, I can just trigger it using a CLI command or trigger it. There are a lot of instruction how to do it with Jenkins and GitLab and GitHub. And by the way, when it's running in the context of a Git system, it also automatically reports back into the pull requests of that Git system. So it's pretty cool. You have full traceability, governance, and approval process built into your with your CI system. And you can also see that stuff. What first thing that we did, by the way, was building those feature sets. So if you go to MLRun UI, you can see all the feature set that I built, their features, their metadata, and so on. When I run the pipeline, I can track those pipeline as they go and see the results of, for example, the results of my training. These are the different results. I can also track it in my Jupyter notebook, as you can see here. And once I've built this pipeline, it automatically, the last step in the pipeline was deploying a serving pipeline. So I can just go and grab this serving pipeline and run requests, essentially invoke, essentially doing HTTP requests against my pipeline, and it will generate the result. Why am I calling it pipeline and not model? Because part of this pipeline, what it does is also doing enrichment. The first you give it a device ID. The first thing that it does takes that device ID and enriches it with all the features of that device, real-time features and static features, creating a model inference, and finally responding with, was there an error, or do we predict an error or not? Okay, so that's on the serving pipeline. And when I'm doing that, and again, it's very simple code, the serving pipeline, it automatically builds, it has all the model monitoring built into it. So if we go into this Grafana dashboard that's connected to MLRun, MLRun also is sort of a Grafana backend. It also has its own UI for monitoring models, but you can actually connect it to Grafana. So I can see the different models that are running in my project with all the different metrics, and I could zoom in to see a real-time matrix. So I can actually see for every feature in my model, what were the actual values in a given time. So I can see if something happens with my feature, maybe the age feature or some other, the temperature feature keeps on going up and up across all devices. So you can actually go and monitor that and see how each individual feature drifts depending on, using different algorithms to calculate the drift and accuracy of your model. So essentially what we've seen here throughout this demo is how I did the feature engineering, very complex feature engineering, doing joins and aggregates and all of that using a few lines of code in Python. Then leveraging library functions and my own code, building a full MLOps pipeline that includes snapshotting data from the feature store, running training, running test and validation, reporting all of that, and deploying the serving endpoint to one or the other cluster, along with all the data engineering and real-time feature engineering for your model and activities of your model pipeline. And the last thing was, you see that essentially it was monitoring all those different activities, and all this monitoring data goes back to the feature store, so you can essentially go and see the production data that was collected and run analytics on the production data. So with that, we can move to the next session of Q&A, question and answers.
Great. Thank you so much, Yaron, for that. That was really, really informative. We're going to go ahead now and ask the second poll. So I'm going to share my screen, go over the question, and then launch the poll for all of you guys to answer. Few questions here is how did you first get interested in MLOps?
Yeah, for me, I think part of the interest was that when I was in graduate school, a lot of the things I studied were really around predictive modeling, but not in a computational way. So like the classic MBA student, believe it or not, is not that far off from beginning into MLOps because they're learning about optimization, statistics. And for me, because I already was working as a software engineer, there was this a golden era, I guess, maybe 2010, where all those things started to merge together. And so that is what really got me interested. And then because I needed to use machine learning in order to figure out who to partner with during our social media company phase, it was kind of an emergent property of the problems that I had. So really it was a combination of academic background, real world problems, coming together. And then it ultimately was a driver for us creating revenue and creating users.
Great, thank you, Noah. If you see a few people here also asked if the recording is going to be available later. And yes, after the session, we will be sending out the recording to everyone. So don't worry about that. We have another question here. Can we train models with real time using MLRun?
Yes. So, first, what I just showed you was a scenario where the data feeds in real time. Part of that demo, the network operation demo, there is actually a simulator that is simulating, is essentially a serverless function that simulates emitting real-time time series data using the MLRun time series simulator. And then you can see that we can actually train based on that data. But we can take it offline and understand what kind of challenge you have and be more specific.
Great. Thanks, Yaron. Another question I think is for both Noah and Yaron, which you guys can separately answer. Do you have any thoughts on the creation of labeled training data and the dangers of poor data quality or lack of domain knowledge in data science? And do you have a preferred solution that addresses those issues? Noah, if you'd like to go ahead.
Yeah, I could talk about, so when I was at the sports social media company, this, believe it or not, was one of the biggest problems that we had. And in particular, the problem was that we needed to first, it's the cold start problem with machine learning, where we need to collect the data for the signals that we were going to harness. And in particular, the data we had to collect was social media handles. And actually, that's a very difficult problem because many people have the same name. So even famous people have the same name. and so this became quite a big issue. Initially, we started with interns collecting data, which is do not recommend. And then ultimately what we ended up doing was using Mechanical Turk, and we created jobs that essentially asked people all over the world to find the social media handles for us and then label the data. So I think this is, a fairly classic approach that still people are using, is that they outsource the labeling to third parties. And so we created an algorithm around that where we would have, let's say 10 different people we would ask the same question who were already kind of pre-trained. And then if, let's say 9 out of 10 of them agreed, then we would say, okay, that's probably the label that we would like. And it actually worked out very well in using the Amazon Mechanical Turk API. It realistically, it took quite a while though. It took probably about a year to get that process going. So for me, I think any platform that allows you to use an API to leverage the human labeling, I think is probably a good place to start and see if that will solve your problem. If it doesn't, then you may need to create maybe even a more advanced solution where you hire people yourself who are experts in this and you supervise it. Apparently, I heard that Tesla, when I was over there several months ago, that they're doing this. Is they originally, they talked about this in their AI day. This is like public information, is that they initially were outsourcing some of the data labeling, but because, I mean, we know there's some life or death situations involving with autonomous vehicles, they are I believe doing it internally as well. So I think the API services could be a good start.
To add, I think there is labeling for offline training when you have sort of historical data last 5 years and someone, you have the time to go and label all that. There is also a chance, what do you do with the retraining? When you want to retrain data, how do you label the data from last week? You have to do it automatically. So in many cases, you could do that automatically. Like, for example, if you have advertisement and you know if someone, based on exposure of some ad, was he clicking or not clicking, there could be automated ways to collect the labels. Part of what we're doing in the feature store and in the model serving is the ability to join events from production with events on the feature store. So you can essentially, every time you're doing a scoring, you get a special token. You can take that token and follow up the progress of that prediction. And then you could essentially go and monitor what happened, what were the actual results for that token, for that activity, that inferencing, compared to the predicted result. And this is essentially a way you can label production data automatically.
Thanks, Yaron. We have time for just one more question, and to all of those that we didn't respond, don't worry, we'll get back to you after this session. So Noah, will you in the future write a hands-on end-to-end MLOps book, or have you already?
Yeah, so I would say the practical MLOps, there definitely are many examples of hands-on end-to-end MLOps. I would say the examples are probably more toy examples though, in terms of they're very simple examples. But the book that Yaron and I are working on, I think, is the next layer up, which is now we're getting out of the toy world and we're getting into really specific end-to-end MLOps. And so that's literally we're in the middle of writing that right now. In addition, this summer, I've actually been working on a course for Coursera around end-to-end MLOps as well, where I plan to go into like a lot of detail about building that. So yeah, stay tuned, and many of those things are coming from Yaron and I.
Very exciting stuff. All right, so before we finish, we have a few more slides. I encourage you all to go on iguazio.com/MLOps to look at a lot of great content, blogs, informative videos, white papers, really educational content that I think you'll all very much enjoy. All right, so with the few moments that we have left, a drum roll, please, for the poll results. So the first question we asked was, where are you on your MLOps journey? So 57% of you said that I'm researching and learning more about MLOps. So back to what I said before, please go ahead and learn more about MLOps on our website. And if you have any questions, please feel free to reach out. 26% of you have already implemented an MLOps solution. 13% of you are actively looking for one. And 4%, this is the first time you're hearing the term MLOps. And the second poll question that we asked was, what is your biggest MLOps challenge? This is quite familiar to us. We've heard CI/CD for ML is a challenge that very much exists. So 32% of you said that, 21% data ingestion and prep, 19% model monitoring, and a tie of 10% for feature engineering and serving, and 7% said, I have no challenges, it's all peachy. Well, you guys are lucky, whoever answered that. Finish off by announcing the book winner raffle. You mentioned that you got a chance to win Noah's book. Can you see my screen here?
Yes.
Yep.
Okay, great. So Eric, Joseph, and Rek, if you guys are here on the call, please reach out to me. And I will also reach out to you to discuss receiving your book. Thank you everyone for participating. And before we finish, I just wanted to thank you all for joining our MLOps Live session 18. And please continue the conversation with us on our MLOps Slack community. We look forward to hearing from all of you. So thank you so much for joining and looking forward to continuing the conversation with you all.